All right, welcome back. So to begin this lecture and building off what we talked about in the previous lecture, let's just stop for a minute. And let's think about how inflation might impact the labor market. So with inflation and with high levels of inflation, will people be more willing or less willing to work? Do we think firms are going to want more workers or fewer workers? Okay, so let's look at this. On the left, the figure on the bottom of the screen, the left one of those, is our labor market in equilibrium. Now, if we consider an increase in the prices that consumers are going to pay, it's going to shift the supply curve to the left or decrease the supply of workers. Because each dollar that workers receive in their salary are able to buy fewer goods, and every non-Scrooge person out there wants money to buy things, not just to have the money. Workers are going to have a higher reservation wage. It's going to take them more money to get them to work in that profession. This means that at each price, in this case, each wage, fewer workers are going to be willing and able to work. Now, leisure or sitting out of work for other reasons will be less costly because they're giving up less money to do so. At the same time, labor demand is going to shift to the right. It's actually going to increase at every wage. This might be a little more unintuitive than the supply curve. The reason why the demand curve is going to shift to the right, or demand is going to increase, is that the marginal production of each worker increases when the price of goods increases. So firm gets more money per worker because people are paying more for those goods. Because now each worker is making more money for the firm, firms are going to be willing and able to hire more. So here on the right is showing that phenomenon happen. We have the supply curve shifting to the left, and we have the demand curve shifting to the right. Now, how far the supply and demand curves shift is going to depend on the change in consumer prices and the change in producer prices. So the demand curve is going to be dependent on producer prices, how much it's going to cost producers to actually for the materials they need to make those goods. Now they can be the same or they can differ. And this example I created so that the consumer prices increase a little bit more than the producer prices, but this doesn't have to be the case. If the producer prices increase more than the consumer prices, then we would see the opposite effect, on the quantity of labor in this new equilibrium. It would actually increase instead of decrease. So we say that inflation will have an ambiguous effect on workers because it depends on which one of those curves moves more. On the other hand, no matter what, wages are going to increase. I'm not going to make you work a lot with two curves shifting at the same time because typically what we see is one of the effects is going to be ambiguous. But when there is inflation in labor markets, we can expect wages to increase. And without more information, without knowing the relative increase in prices, we can't say what the effect is going to be on the number of workers. So the next section in your textbook is about the Phillips curve. I'm going to skip that because we're not teaching fiction, and we're going to move straight on to equilibrium across different labor markets. So right here, what is, we have an example. So what is behind the difference here between the teacher in Boise, Idaho, and the software engineer in Boston, Massachusetts? So the teacher in Boise, Idaho is making on average $51,000. I think that was last year's number. And software engineers in Boston, Massachusetts, on average, make about $120,000. And that changes depending on exactly how you define software engineer. So this is a pretty big difference. A teacher in Boise could learn how to code, move to Boston, and make $70K more. So why does this exist? Well, we think if a lot of people did this, we would see the wages offered to entice teachers to stay in Boise, Idaho, slowly start to increase. They need to offer them more and more to convince them to stay instead of going to school and then moving across the country. At the same time, if a lot of people moved from areas where it was cheap, whether we're looking at just teachers in Boise, Idaho, or across the country in all different professions across the country, we'll start to see the wages at software engineers creep down as more and more workers are willing to work in this industry. So let's look at two labor markets, which are cleverly named labor market A and labor market B. And we'll look at the supply and demand for a single profession within those markets. In this case, the only difference between those two markets is the location. So the workers themselves and the jobs are exactly the same. They have all the same characteristics on average. So if we saw a wage differential like this, in market A, the average wage that workers are making is $9 an hour. In market B, it's only $8 an hour. So we have this $1 difference between the two markets. So typically, if wage earners in market A are earning more, we would expect some workers from market B to migrate to market A. And what this would do is end up driving down the wage in market A and driving up the wage in market B. Because in market A, we end up increasing the supply of workers. That's going to shift the supply curve to the right. And we're going to see a move, if we look at the bottom part of the panel, it's for market A, to move from S1 to S2. So where S2, this new increase supply curve, where that crosses the demand curve, is going to be at a lower point. In this case, it's at $8.25. At the same time, in labor market B, because we have people leaving the labor market, they're now moving to market A. That's going to shift the supply curve to the left. Now, where this new supply curve S2 crosses the demand curve is going to be at a slightly higher point. Again, we're in this example, we're moving towards the same price until they're exactly the same. So imagine this is like two cities next door where it's pretty cheap to move from one city to another. In this case, it's also moving to $8.25. So eventually we settle at a point where both labor market A and labor market B have the same wages that they're paying employees. But what if there's something else going on? So let's look at another example. It could be that labor market A and B are in the same physical location. The difference between those two markets is market A is for higher skilled employees in this specific industry, and labor market B is for lower skilled employees in this same specific industry. If that's the case, then workers in market B are going to have an incentive not to move this time. Now it's an incentive to build their skills or develop human capital, as economists would say. So we'd see the same thing play out. We would see workers leave market B for market A. Now they're doing it through building skills or undergoing formal education or getting like on-the-job training certificates. That's going to decrease the supply of workers in market B and increase the supply of workers in market A. And we're going to drive them towards the same wage. Now, in both of these cases, are we likely to see the same wage in both markets? This is highly unlikely to occur. And it depends on the differences between those markets. There's going to be a cost for any adjustment. So whether it's moving to a new city or education in our two examples. As long as the cost of moving or the cost of education is lower than the wage difference for moving, people are going to move. If there's some gain to be had in excess of the cost of whatever that move is going to be. And people are going to move from one labor market to the other, again, whether it's education or physically moving, until the cost of moving, or the cost of education, the cost of going from that one labor market to the other is equal to the wage increase that they get. So in the long run, we can see wage differences persist between locations in the same industry or between skill levels within the same industry. Now, sometimes, like your text goes into this in a little bit more depth, there's a skill that's so rare, something like pro athlete or CEO, that people are unable to just enter the market. And they don't really bring down the average wage. We don't see the wage falling like we do from the higher skill, the market A here. I can't just decide one day to be a good enough basketball player to guard Nikola Jokic, or I can't replace Jamie Dimon at JP Morgan Chase. I can't just decide to be skilled enough to do that. It takes a very specific skill set. For basketball, it takes physical attributes, something that most people just can't do. So when these large wage differentials persist, and in these extreme cases I gave out, they persist and they're quite large, we refer to these as economic rents. Now, the existence of wage differentials will also cause employers to shift their labor demand. So we're not just looking at supply, now we'll look at demand, because the same thing happens here. So we've seen this with outsourcing over the past few decades. So moving manufacturing, different levels of the earlier stages of production from the United States to other countries, but it's much older than that. Textile manufacturing in the 20th century moved from New England, where wages were relatively higher, down to the South, where wages were relatively lower. And the firms did this because they could pay their workers in the South less. Because low skilled workers, um, because they command lower wages, companies have an incentive to figure out how to use lower skilled employees in production. Typically, it's going to be in earlier stages of production, but that's not always the case. Here we have graphs with, again, market A and market B, showing how changes in demand can reduce or eliminate these wage disparities. So as demand for low-skilled workers in market B begins to increase, so we move from demand curve D to D2, that's going to increase the number of low-skilled workers that are being demanded by firms. It's also going to increase the wages that they're being paid. In this case, we're using the example of $8.25. It's moving up towards that $9, which we see in market A for the higher skilled workers. At the same time, because firms are now shifting their production so that they can hire more lower skilled workers, they don't need as many higher skilled workers. So in market A, we see the demand curve shift to the left for them. So the demand is going to decrease. In the long run, the adjustment that takes place here depends on the ability for firms to substitute lower skilled workers for higher skilled workers. In practice, there's only so much substitution a firm can do. You need some, really highly skilled workers for your firm. So to take an extreme example, you can use LPNs more in delivering healthcare, but you can't use them for surgeries, even though surgeons cost more. There's ways to incorporate lower skilled professionals into things like healthcare, into whatever product or service you have, but they can't replace everyone. So because of that, we don't expect adjustments in demand to eliminate the disparities in wages between market A and market B. If it's something like we're looking at two nearby labor markets, so their areas are really close together with slightly different costs of living, we can see the changes in demand eliminate the difference between the wages. But we will see, in general, we will see some movement in this direction. Okay, so although